Alright, today we're going to be balancing this chemical equation here. It is a single replacement or displacement reaction, just kind of a fun fact. So I'm just going to write that out here. Okay, so let's go ahead and try to solve this out. So I will start off by counting out the different elements that I have. So I have lithium, I have hydrogen, and I have oxygen, right? We do have a polyatomic ion of OH, or oxygen and hydrogen, which gives us hydroxide, right? But this is not on both sides of my equation. It's not on my reactant side. So I'm just gonna break it into the different elements it is, and that is oxygen and hydrogen. If it was on my reactant and product side, on both sides, then I would just treat it as just one package and just one atom. But it's not, so we're not gonna do that. So lithium on the reactant side and on the product side. So lithium on the reactant side, you have you have two hydrogens, and you have one oxygen. On the product side, you have one lithium from here, you have two hydrogens from here, and then you have one oxygen from here. Is this correct? It is not correct. And that's because in the hydrogen part, I'm actually not accounting this one lonely hydrogen here, right? So what we need to do is we need to add this 2 coming from this hydrogen gas with this one lonely hydrogen to give us a total of 3. So we actually have 3 hydrogens on the product side. And that is what is unbalanced about this equation, because you can't just magically create another hydrogen. That violates the law of conservation of mass. You must have the same amount on both sides, so you're just transforming them, not creating or destroying them. So what can we do to solve this? Well, what I want to do first is this is not an even number, but this is an even number. That's very, very bad. We want this to become an even number. So how can we do that? Well, we can add a 2 here. By adding this 2, this whole count gets completely voided, and we have to recount it. So we have 2 hydrogen now, because remember, we're creating 2 of these lithium hydroxides, so therefore we have 2 of those hydrogens from the hydroxide. So now we have 2 plus the already existing 2 from the hydrogen gas, so therefore we have a total of 4 in our product. That is an even number, so we'll use this. But this also changes the count for lithium, so let's change lithium's count to 2, and also oxygen's count to 2 as well. Cool. Let's move on to the reactant side. None of it's still balanced yet, but what we were able to change was the ratio. Now the ratio is even, so it's much more easier for us to change the coefficients. Let's start off with hydrogen first. So what I can do is I can just add a 2 here, and that would cancel this out to a 4, because remember, 2 times 2 is 4. And then this would also affect the oxygen to 2. So now you can see that the hydrogen is good, and then the oxygen is also good. Now, the lithium is not good, it's not balanced. So what we can do is lithium is by itself, so we can just add a 2 here, and therefore we get a 2. So now you have 2 on both sides for lithium, you have 4 on both sides for hydrogen, and you have 2 on both sides for oxygen. And the final answer, the final grand answer would be 2 lithiums plus 2 waters, which is turned into 2 lithium hydroxides and hydrogen gas. So the coefficients come in this form. All right? And that is the answer completely done for you.